Hello, Algebra 2 students. Welcome back to another episode of your Checkpoint Study Guide videos. We're going to be looking at Checkpoint C. A lot of you had a problem with this question when it came to doing this on your own. Now, I understand this could be a little bit tricky, but the key point in this is reading the problem. It says a party will have hexagonal tables placed together with space for one person on each side. So what's going on here? So we have hexagonal tables, right? That tells me that each table is going to have 6 sides. Not only that, one person is going to be on each open side. The key word is open side. Okay? Complete the table showing the number of people, P of n, who can sit at n tables. So let's complete the table. Again, the key word is open side. So if I have just one table, I can just see that I have 1, 2, 3, 4, 5, 6 people sitting at that table, right? So that's why I got for one table that I can fit 6 people. Now let's see how many people fit at 2 tables. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 2 tables, I can fit 10 people. Now, I know some of you are saying, but mister, I can fit 12. No, remember my keyword that says open side? This side is technically not open because the 2 tables were put together back to back. That's why I cannot put anyone at this side for either table, okay? Let's do the same thing for number 3, okay? For number 3, I can see that I can put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. For 3 tables, I can fit 14 people. Okay. Again, the 2 sides that connect tables 1 and 2 and 2 and 3 cannot be used because they're not open sides. They're literally right next to each other, so no one fits. Based on my table, what does it look like? I have a pattern. Sorry, what pattern does it look like I have for that P of n row? I go from 6 to 10, 10 to 14. It looks like I'm adding plus 4, right? Plus 4. So now I don't even have to draw out any tables. I can just say, okay, 14 plus 4 is going to be 18. 18 plus 4 is going to be 22. Perfect. That's all I have to do for the table. Explain why P of 3.2 does not make sense in this scenario. So why can't I have 3.2? What does the 3.2 represent? Well, if you see, P of n, they tell you right here, P of n represents the number of people. So P of 3.2, what does that mean? That I have 3.2 people. So it does not make sense. It does not make sense. It doesn't make sense because we cannot have 3. Whoops, I can do better. Give me 1 second, y'all. 3.2 people. It does not make sense because we cannot have 3.2 people. Hopefully that made sense, right? That answers number 2. Now let's answer number 3. We need a recursive formula. So recursive and nth term. So we need both formulas, okay? So let's look at the recursive. That one's a little bit easier. All right, so we have to still use P of n. P of n equals, well, how do we show the previous one? We should already be experts. P of n minus 1, parentheses. What was my pattern? My pattern was plus 4. Nice. And then what was my first term? P of 1 equals 6. Boom, this is the recursive, okay? Recursive. Let's look at our nth term. Nth term, still I start with P of n equals, well, first I want to identify what is my first term. My first term, if you can see on my table, it was a 6. So that means I'm going to go ahead and put a 6 here. What was my pattern? My pattern was a plus 4 according to my table, right? So it's plus 4, 6 plus 4. And then every time I want to go up in a value, what letter was I using? Well, I was using n, so that means it's going to be 4 times n, right? Where n, to get my first value, if I plug n is equal to 0, I'm going to get my first value of 6. So n is greater than or equal to 0. And this one right here, that's my nth term formula. Nth term. Nth term, okay? If you have any questions, you're more than welcome to raise your hand, ask a question, and I'll be happy to respond. But after that, we just have one more video left to go. See you in the next one.